All right, good day to everybody. We are going to continue with our discussion. Still on chapter 2, Our topic is component method of adding forces. So we're going to add forces we're going to solve for the resultant of forces which are concurrent in nature. So previously what we have discussed was solving for the component of a force in three dimensions. So ngayon, we're going to solve for the resultant of forces, concurrent forces, both in 2 and 3 dimensions. All right? Okay, so we need, of course, your knowledge in our previous topics before, how to add. We're going to apply those um, concepts, yung mga concepts na before na discussed, we're going to apply it here. Okay, so how do we add forces? How do we solve for the resultants? Again, as I have mentioned many times already, sa chapter nito, we're going to do two things only, We're going to add forces or solve for the components of a certain force. So when we say adding forces or solving for the resultant of forces, pares lang yun, no? When we say add vectors or add forces, we mean we are going to solve for the resultant. And when we solve for the resultant, that means we're going to convert a lot of forces into a single force. And then the second one is solving for the component of a certain force. So we have a single force, we're going to solve the component of that force relative to a certain axis, So yan. Yun lang ulit ang ginagawa natin. So it's in 2 dimensions or 3 dimensions. So this time, we're going to solve for the resultant of concurrent forces using the component method. That means we're going to, yung axis natin ay perpendicular. So para magamit natin yung component method sa pag-add ng resultant ng concurrent forces, it means the axis should be or the axis should be perpendicular. All right. And what else? Concurrent forces. Ano ba ibig sabihin ng concurrent forces? So what we have dealt before in yung mga sinolve natin, examples natin, mga problems, plates that I gave you, those are concurrent forces. Those are co-planar concurrent forces. So when we say co-planar, that means the forces lie on the same plane. That means same plane, so xy plane or xz plane, yz plane, so depende, no? So that means all forces lie on the same plane. And then concurrent means, kapag concurrent, it means the forces intersect at a certain junction. So meron silang junction. So meron silang point of intersection. So forces, meron din kasi mga parallel forces, which we will deal later on. May mga coplanar but not concurrent na forces. I-discuss natin yan later on sa ibang chapter na. So what we have dealt and what we're going to deal in this topic is our forces which are coplanar and concurrent. Okay? So how do we add forces or how do we solve for the resultant of concurrent forces? So we'll just apply what we have discussed before. Okay, that is, ano yung mga natin? Para i-add natin yung mga forces, very simple lang yung idea. For example, we have concurrent forces, say F1, F2, and F3. Ang gagawin lang natin, we are to convert all these forces into their equivalent components along the x and y axis. So we have this is x, y axis. So i-solve natin yung component ng F1 along x, component ng F1 along y. So i-convert lang natin F1 gawin nating components along X and Y. Okay, so that means yung action ng F1 relative to this particular, let's say, a body or a particle where it is applied is also the same dito sa may action ng F1X and F1Y. Okay? So basically, F1 is just equal to F1X plus F1Y. Okay? So when we add this one, addition of vectors. Ano? So parehas lang yan. So isolve din natin yung component ng F2 along Y, and then component ng F2 along X, and then component of F3 along X, and then component of F3 along Y axis. And then to solve for the resultant of these forces, solve natin siya, convert natin siya sa iisa lang, i-add natin yung, so i-add natin lahat ng X forces along X axis. Okay? And then add din natin lahat ng forces along Y axis. Okay? So lahat of course we're going to consider yung direction ng forces. So when we add yung mga components, we're going to consider the direction of these forces. Okay, so pag ito yung sign convention, I think for most, if not all of the books, no, when we're dealing with two dimensions, no, so two-dimensional force systems, so to the right, this is the origin. To the right, of course, positive. Upwards kapag vertical, that is positive. Kapag to the left, negative naman ang X. Kapag downwards yung direction, negative yung Y. So in this case, Fy3 is minus, F2X is minus, or negative. Ayan. So that's how we do it. And after summating all the components along X and summating all the components along Y, that would now be equal to the X component of the resultant. So this is Rx. And of course, the summation of all Y components would be Ry. So ito na yung components along X and Y axis ng resultant natin. So to solve for the resultant, that is equivalent to Rx squared plus Ry squared, or that is simply equal to the summation of Fx squared plus summation of Fy squared. Alright, so that's how we solve for the resultant of concurrent forces in 2 dimensions. Kapag 3 dimensions, mag-add lang tayo ng another axis, which is the Z axis. So for 3 dimensions naman, the resultant, of course, is equal to the summation of forces along X squared plus summation of forces along Y squared plus summation of forces along Z squared. Okay? So summation of Fx is just R sub X, summation of Fy is just R sub Y, and summation of Fz is just R sub Z. So these are the components of the force, the resultant force along X, Y, Z axis if we're dealing with three-dimensional force systems, no? Concurrent force systems. Okay? So ganun lang kasimple yung ating pag-apply ng component method for adding concurrent forces or finding the resultant of concurrent forces. Alright? So very simple yung ating method, no? Okay? Now let's have an example dito sa paggamit ng component method sa pag-add or pag-solve ng resultant ng concurrent forces. Okay, let's solve this first problem. Find the resultant of the given system of forces using the component method. Okay, first step natin is to solve for the components of each force. No? Solve for the components of each force along the X and Y axis. Okay, so let's say, lagyan na natin ng pangalan ng bawat force para hindi tayo nalilito. So ito na lang gawin natin. Red yung nakuha ko. This should be F1. Lagyan ng pangalan. And this is F2. And this is F3. O, pwede namang hindi nalagyan ng pangalan. You can not name each force, but it would be more convenient. I think it would be more convenient for me to explain, for explanation purposes. Nalagyan natin ng pangalan ng bawat force. Now, solve natin yung component ng F1 along X and Y axis. So, ito. This is F1X and this is F1Y. Okay? So, how do you solve for F1X, F1Y? So, if this is F1Y, parallelogram method pa rin. There's also F1Y. Napahaba yung pagkakasulat ko ng force nyo dyan. Anyway, ganyan dapat. Parallelogram method. No? Ayan. So, 35 yan. So, this angle is 90 minus 35 degrees. But we'll just use the given angle there to solve for the components of each force. So, if this is F1x, this is also F1x. Ganun yung direction niya. Alright, so F1x is equal to 88 pounds cosine, so adjacent side yan, of 35 degrees, and that is equal to 72.085 pounds. Okay? And then F1y is equal to, what is F1y? Opposite. So, opposite side of the triangle. So, 88 sine of 35 degrees. That is equivalent to 50.475 pounds. Alright, so that is F1x, F1y. Okay, so both components are positive. So F1x is directed to the right, F1y is directed upwards. So, positive sila. Next, components of F2 along X and Y axis. So, yung X component natin, ito, this is F2X. Tingin lang siguro. And this is F2Y. Wait lang. Okay. And if there is F2Y, this is also F2Y. And this is also F2X. Ayan. So, solve natin yung X and Y components of F2. Okay, so F2X is equal to X component. Let's just use yung given angle natin, 75 degrees. So, opposite side siya. So, that is, so since F2X is directed to the left yung direction niya, so negative siya. No? So, negative 65 sine of 75 degrees, and that is equivalent to negative 62.785 pounds. Visible ba? And then F2Y is equal to, so F2Y is upwards, so positive siya. So we have 65 and an adjacent side then, so cosine of 75 degrees. That is equal to 16.823 pounds. Okay. And lastly, we solve for the X and Y components of F3. So, saan yung direction ng X component ng F3? This is F3X to the right. So, that's positive. And then we also have F3y downward, so negative yung F3y natin. Okay, that's F3y. This is also F3y, force triangle, or we can use parallelogram method to solve it. And then F3x is equal to adjacent side. So we have 125 cosine of 45 degrees. That is equal to 88.388 pounds. And F3y is downwards. So F3y is downwards, so that should be negative. So negative 125 sine of 45 degrees. That is equivalent to negative 88.388 pounds. Okay? Alright, I think we're good. Kita ba? And then we summate. So next, so first step natin is to solve for the components of each force along the x and y axis. And then next is to summate forces along x, all components along x, and then summate all forces along y axis. So we summate forces along x-axis. So lahat ng forces along x-axis, ito, lahat ng components along x-axis. So we have F1x is 72.085 minus, kasi negative ito. So plus negative. So minus, idiretso natin. 62.785 and then plus 88.388. So ito na yung ating summation of force along x, which is equivalent to 97.688 pounds. Okay. And this is equal to the x component of the resultant force. Alright? And then summation of forces along y-axis. So all vertical forces. Lahat ng vertical. Kanina lahat ng horizontal. So remember, x-axis is the horizontal axis. And then the y-axis is the vertical axis. Okay? Ayan. So, lahat ng y force components along y. So, we have 50.475 plus 16.823 minus 88.388. So, that is equal to negative 21.09 pounds, and this is the y component of the resultant force. Okay? Now, how do you solve for the resultant? So, yung resultant force natin is simply equal to, so given na yung, di ba, right triangle tayo, right triangle, x tsaka y. Solve natin yung solve natin yung resultant, the hypotenuse. So that is simply equal to rx squared plus ry squared. So the square root of the quantity r squared plus ry squared. So we have 97.688 squared plus minus 21.09 squared. Alright, so the resultant force is equivalent to 99.39 pounds. Yung ba hinihingi sa problem? Tama. So, yun yung resultant force natin. So, the direction of the resultant force can be solved using trigonometry, So, trigonometry, yung direction ng force natin. How do you solve for the direction of the resultant force? So, look at so, nasaan ba yung resultant force natin? So, kaya yung location ng resultant force natin. So, the resultant force, you look at the values of Rx and Ry, or the summation of forces along X and summation of forces along Y-axis. So, this is positive. X is positive, and then Y is negative. So, saan kaya yun, banda? So, aling quadrant yon? Yung x ay positive, tapos y yung negative, yung y niya. So which quadrant yun? Kill. So x positive, y negative. So basically nandito yung ating resultant. So yung direction niya from x axis, let's say angle theta. How do you solve for the direction of the force theta? So ito yung Rx natin, ano? Rx, and this is Ry. So force triangle. So this is Ry, and this is for theta. Oh, arctangent of opposite over adjacent, Ry over Rx. Okay, arctangent of Ry over Rx. Okay, so theta, so let's say, so tangent theta is equal to opposite over adjacent, so Ry over Rx. Yan. So theta is the arctangent of Ry, which is 21. So pwedeng negative or positive, negative, pwede rin naman. 21.09 all over Rx. So the angle theta is equal to 12.18 degrees. So yan yung direction niya. So negative yan kasi negative dito. Pag ano yung direction niya, clockwise yung measurement. Okay. Pwede namang, since alam naman natin na ganun yung direction, you can neglect the negative sign here. So that the result would be 12.18 degrees from clockwise from the positive x-axis. Okay. So we can remove that sign. So theta is 12.18 degrees from measured clockwise from the positive x-axis. All right. So that is problem number 1. So that's how you solve. That's how you use component method for solving for the resultant of concurrent forces. Okay. So we'll continue. We'll have another example sa next na video.